Hello and welcome back to Physics Galaxy. And today we're going to solve a question from Tifr's previous year exam. And the question states: Consider an electric dipole of strength P placed near a grounded infinite conducting sheet in the xy plane at a distance d from it in the z direction as shown below. The center of the dipole C is fixed to a pivot, but the dipole is free to rotate about the x-axis coming out of the page. So x-axis is coming out of the page. Okay. What is the magnitude of the torque on the dipole when the angle between the dipole and the positive z-axis is pi minus theta? So this is the angle pi minus theta. And here are our four options. So what we have to find is the magnitude of the torque on the dipole. Okay. So this dipole, we have to find the torque on this dipole. Okay. Torque on the real dipole. Torque on the real dipole. Right. Now here is our configuration. So this is our real dipole, and because we'll use method of images, here is our imaginary or image dipole. Now the torque, we know torque equals to P, that is the dipole moment of the real, this cross the electric field in the vicinity of the real dipole. Now the electric field in the vicinity of the real dipole will be produced by the image dipole. Okay, so let's find first of all the electric field due to an image dipole. Okay, so remember torque equals to P cross E. P is the real, okay, dipole moment of the real dipole cross electric field due to an image dipole. So electric field due to an imaginary dipole will be simply P imaginary divided by 4 pi epsilon naught r cube times 2 cos of theta r cap plus sine theta theta cap. Now we know that magnitude of the real dipole will be equal to magnitude of the imaginary dipole or image dipole, so we can omit this pi labeling here from here. Okay, so this will be the electric field due to an image dipole in the vicinity of the real dipole. And what is r? R is this distance from the image dipole to the real dipole, and that is equals to 2d, right? So this is 2d equals to r. So r equals to 2 times d. And also theta, what is theta? Theta here will be this angle, and this angle we know is actually pi minus theta, right? So we have to substitute not theta, we have to substitute pi minus theta. Okay, and so this will be the actual angle here. So electric field will be simply given by P divided by 4 pi epsilon naught r cube, that will be 2d whole cube, that will be 8d cube, then twice cos of pi minus theta equals to minus cos of theta r cap plus sine of pi minus theta, because we have to substitute pi minus theta in place of theta. Sine of pi minus theta is sine of theta, simply sine of theta theta cap. So we got our electric field, right? This is our electric field. Now what we have to find is E of the real dipole. Now what is P of the real dipole? Let's see from here. So this is our P, that is the magnitude, that is the dipole moment of the real dipoles P. So because we're finding everything in terms of image dipole, so it will have this component as a R component, that will be P cos of theta, but minus, because it's in the downward direction, minus P cos of theta, and this component, that will be P sine of theta. P sine of theta. So what I did here, so this was my dipole. So this was its first component, that is minus P cos theta in the direction of r cap, and this was its P sine of theta in the direction of theta cap, right? So my P is, that is P equals to minus P cos theta in the direction of r cap plus P sine theta in the direction of theta cap. Now I just have to do the cross product. So let's do the cross product. Torque equals to P cross E. So P, I know it's minus P cos of theta r cap plus P sine of theta theta cap, then cross with this. So this is what I had to cross it with. So let's let P divided by, this is 32 32 pi epsilon naught d cube, then minus 2 cos theta r cap plus sin theta theta cap, right? So let me take some constants out. So torque will be equals to, I will take p common, so p divided by 32 pi epsilon naught d cube. So I will have minus cos theta r cap plus sin theta theta cap cross 2, sorry, minus 2 cos theta r cap plus sin theta theta cap. Okay, now it's just a cross product. So p divided by 32 pi epsilon naught d cube. Now this will be crossed with this, but it has r cross r, so it will be 0. Then this will be crossed with this. It has r and theta, so it will be minus cos theta sin theta. Then r cross theta, r cap cross theta cap. We know it's phi cap, but here phi cap is in the minus x direction, so minus x cap, minus x cap. Again, then this will be crossed with this, so plus, sorry, minus, because minus 2y sin theta cos theta, then theta cross r cap. Theta cross r cap is plus x cap. So x cap. Then theta cross theta will be 0. So this is it. So we have torque equals to p divided by 32 pi epsilon naught d cube. We have sin theta cos theta in the direction of x cap minus twice sin theta cos theta x cap. Or I can write p divided by 32 pi epsilon naught d cube minus sin theta cos theta x cap. Okay, or I can write as sin theta cos theta equals to half of sin 2 theta. So I can write simply minus p, sorry, it was p square, because here p and p, so p square was p square, p square 32 pi epsilon naught d cube, and it will be sin 2 theta divided by 2, and that will be our answer in the direction of x cap. So p square sin 2 theta divided by 64 pi epsilon naught d cube, minus x cap. But because we had to find only the magnitude, so it will be simply this p square sin 2 theta divided by 64 pi epsilon. So which is our option number first.